Live from your local news leader, Karina Rubio, Matthew White.
Central Illinois' most accurate forecast with meteorologist Jacob Dickey.
You're watching The Morning Show at 9 on WCIA 3.
Welcome back, and thank you for sticking with us, Central Illinois. We are now turning to our Wise Guys segment with our member Paul Kwiat, who spoke with us last time about lights and maybe how they can be faulty and go out. But this time we are talking about blinking holiday lights.
We are indeed. Happy holidays.
Happy holidays to you, Paul, and your family.
Thank you. So there's one more thing we have to talk about from last time. So I just have a normal light string here, and if one of the lights is completely removed, you see that the light switch goes out. The whole string goes out. I'm going to put that back in. But you might have noticed when your own lights go out, hopefully that doesn't happen, because if that happened, then if only one of 80 bulbs went out, the whole string would go out. It'd be impossible to keep it lit. So they have kind of an extra thing, and so this is our first graphic on this. That there's this thing that says a high resistance shunt. So when the filament burns out, that wire across there has the current starts to flow through it, more current flows through it, and it heats it up and it burns away a little resistance, and suddenly that becomes a short. So then it's like that whole thing is connected and then current can flow through. So that's how they can make it so that even though one bulb burns out, the rest of the string can keep going. Okay, so what we're concerned with, though, if we come back to me, if I switch in one of these other fancy bulbs with the red tip, okay, then we see that everything goes bright for just a second, right? And then we're going to see that we're going to start getting a blinking action. So the question is, why do we get that blinking? What's going on there? So this is a special bulb, and if we go back to the first graphic, there's kind of a close-up of that bulb. It makes it a little easier to see. Sorry, the next graphic. Great, so this is what a blinker looks like. And you got this kind of wire on the side. It looks a little bit curved. So what's going on with that, if we do the next graphic, has to do with the fact that most materials, particularly metals, when you heat them, they will expand. You might have heard that before. And they don't expand a lot, so this is just showing that the fractional change goes like alpha times the change in temperature. So alpha can be pretty small. So you see it's like 1 part in 100,000 or something. But the point is that different metals will have different expansion coefficients. So for example, copper will expand more if you heat it than iron, if you heat them by the same amount. So if we come back to me, so I have here, this is just a strip that has one metal on one side and one metal on another side. And if I just heat these, so one of them is going to expand more than the other one.
Paul's got a flame.
I do have a flame. One's going to expand more than the other one. And we see now that in fact that it bends. So the one on this brass side expanded more than the one on the other side. And so then it bends away from me and it curves. Okay, so what does this have to do then with our light switch? If we come back to us, so
cool it off.
Just want to cool it just a little bit. Okay, so what I've done now, so this is a model of lights. So I've got some normal lights. I've got a regular switch that when I close the switch here, when I close the switch, all the lights go on.
That is cool.
Great, so now I'm going to keep that open. And now instead, I'm going to use this bimetallic strip that has two pieces of metal. And that strip is going to be the thing that now closes. So now the lights are on.
And they stay on.
And they stay on. So, but what happens in the light bulb, in these blinker lights, is this switch is very close to those lights. So when those lights are on, this switch is going to heat up. So when I heat this up, this metal up, assuming I can get it to go, there we go. When I heat this metal up, it's going to bend, and when it bends, it breaks the connection, and then the lights, then the lights go off, and then they heat up again, and when they heat up again, that's like me heating this up again, and as I heat this up, this bends, it breaks the connection until it cools down enough for it to come back on.
Wow.
Okay, so that's how the thing is blinking. Now there's one more kind of mystery, which is that why is it when I have the blinker light in this string, when it goes off and it breaks the connection, why do all the lights go off? And in particular, why isn't it the same as the other lights? So with these other lights, when the connection was broken, right, the other lights would stay on, right? When I said a normal light, if it burns out, the other lights stay on. In this case, when it burns out, the other lights don't stay on. They all turn off, right? So if we do the last graphic that we have here, we'll see that it's a little bit different. So the blinker's on the right and the normal bulb is on the left, and the blinker doesn't have that little high resistance shunt. So when the thing opens on the blinker, it just stays open. There's nothing that burns across and short circuits it. If it did, what would happen, it would just blink once and then it would be completely over. It would just be shorted the rest of the time, and then that wouldn't be very useful. So okay, so that is how blinking Christmas tree lights work, and why it's nice that if one bulb goes out, they don't all immediately go out.
I'm sure we're hoping at home, though, nobody's Christmas lights go out.
We hope that none of the lights go out, and if you ever have to try and find a broken light, it's not necessarily the easiest thing. So,
Well, we just thank you for the wisdom that you gave us to maybe look out for that, Paul.
Great.
All righty. Well, of course, happy holidays again to you and your family.
Thanks so much.
And we'll look forward to seeing you right here on the morning show after this break.
Sounds great. Bye-bye.